All right, so on Monday's class, we started looking at distribution samples of a group of them. So we're looking at the sample means in that situation. So we've done in the past and all the things, we've talked about mean, and then we've done proportions, which are very similar to it. That's what we're going to look at today. We're going to look at some proportion problems. So just to refresh your memory, when we're looking at proportions, these are ones that we're going to have to be able to figure out. So you got to find your mean and your standard deviation for these problems. So the mean will be the mean of the sample proportions. So they will typically give that to you. And your standard deviation is basically the same as what we had before. It was p times 1 minus p, but this time it's divided by the n. So a couple little changes in the formulas for these. However, once we go through and see it, you'll notice the process is very, very similar. You will need your z-tables, so if you have those, take those out. Yes.
With the square root part, I've seen it with like a longer thing on the left side. Is there any difference, or is that just like a?
What, this?
Yeah, like I've seen that line extend.
Oh, it doesn't make a difference.
Okay.
Yeah, that doesn't matter. The key is where the top line goes over. Make sure it's only over what you're actually doing the square root of. And in this case, you're doing the square root of everything. So, all right. So let's do some problems. Because that's basically all that's new. Suppose we have a sample of 400 people that used to perform a taste test. So the big old Pepsi versus Coke challenge. If we make the assumption that the population prefers Pepsi is really a 50-50 split, what is the probability that less than 44% or 0.44 of the persons will prefer Pepsi? So what are the things that we need to do the problem? Go back. Yeah. Yeah.
What if it's 0.44 of the person? Does that mean like that amount of the sample?
Yeah, so it's 44% of the sample that I'm doing. So if I do a sample of 100 people, what's the probability that 44 of them are going to like it? No. No, it's 0.44 of the persons in the sample. All right, so what are the pieces of information that I need? I need N. And what else? I need P. So I need N and I need P. So I need the sample mean and I need the how many people. All right. Big. Okay. So in this case, P. And what's that? So what's P? That's one of the two pieces in it. What's the other? We have two probabilities in this problem, right? The 0.44 and the 0.50. So which one is the assumption? So what is the fraction of the population, I should say? So we're looking at that as 50-50, right? So that's going to be my P. The 0.44 is going to be my X when I'm doing my Z-score and those things, because that's what I'm trying to test against. So that is going to be my P, because that's the, if you look back here, it says the sample proportions equals the population proportion. So the population proportion is 0.5. And my N in this case is 400. So based on that, we can find our mean and our standard deviation. So my mean is the same as P. So that's just 0.5. My standard deviation is the square root of P times 1 minus P over N. So 0.5 is 1 minus 0.5 divided by 400. Yes.
Oh, never mind.
So actually, since I'm going to do a bunch of these, I'm just going to do it this way. All right, so we've got our standard deviation is 0.025. So unlike the mean ones, we have to calculate these couple things. All right, so now they want to find the probability that less than 0.44 of the people prefer Pepsi. So if we look at a little bell curve, in the middle was 0.5. So 0.44 is over here, and we want less than that. So we're looking for that section over there. Yeah.
How would we write that? Like, the probability of. Like, oh, okay. I thought it was more.
Nope, that's it. Actually, let me write it over here because I'm going to put the answer next to that one. Now, to find that, we need to find our what? We need to find our z-score. So remember z, x minus the mean divided by standard deviation. We do not have to do the square root of n on this one because we've already done it. Okay. So if you remember the last on Monday's class when we were doing it, we had to do the square or the standard deviation divided by the square root of n. Since we're already doing technically the square root of n already up here, we do not have to do it again. Okay. That makes sense? Okay. It's just a little extra formula to remember. All right. So we've got now my x in this case is the 0.44 minus 0.5 over 0.025. So my z-score is negative 2.4. I forgot to grab my z table. Hold on. All right, so negative 2.4. So we look at our Z table. Negative 2.40 is 0.0082. Yes.
That's the right? There's no like continuity correction.
There is no continuity correction.
Okay.
Yes.
I'm just a little confused why if the if it's 0.44 of the people, then why aren't we like looking at the Z table and getting, I mean, like taking the probability of that and getting the Z from it instead? Like if it's asking for disproportion, then
So we have to look at it's as compared to the mean. So it's not 44%. Okay. It's like I know exactly what you're asking, and I'm trying to figure out the best way to explain it. Let's see if I can. All right. So when we're looking at the curve for probability, we have a standard deviation. So it's not a percentage of it. So it's not like 44%, because that'd be really close to the 5 over here, or we're looking at 44% of the curve. We're looking at 44% of that people. So we're looking at like a whole bunch of different samples.
oh,
How many of them would come out with a 44% chance? Does that make sense?
yeah, just weird wording.
Yeah, and I totally agree with you. It is absolutely weird the way it's worded. It's not necessarily a percentage as in we're looking at the curve piece. It's
I think
Yeah.
other ones it won't have the values, so
yeah, 0.5.
well, yeah, it's just a little confusing in that sense, but yeah, okay.
Yeah, they're going to vary. It depends on what we're talking about in that respect. But yeah, the mean's not always going to be 0.5. All right, so we got 0.0082. So do I have to subtract from 1, or is that my answer? That is my answer, because I'm looking for the left. So 0.0082. All right, so the question is what does that mean? Yes. Oh, I thought you raised your hand. Okay. What does that mean?
But
So if I did the survey and I got 44%.
the 0.5 isn't true.
Probably not. And that's what we're going to eventually get into. It's like, what does this mean? Like, we got this number. All right. So the chances of me getting, if it was truly 50-50, the chances of me getting 44 out of 400 or 44% out of the 400 people there is less than 1%. So probably not going to happen. So in that respect, they probably prefer Coke a little bit more. So, yes.
Because we're working with a sample, would that mean like this survey that is done multiple times, and there's like this 0.0082% chance of this distribution, like of it landing on the 0.44.
Or less.
Okay.
Yeah, this is a 44% or less. So in this problem, they just want to figure out what's the probability that would occur. If I did another random sample of 400 people, what's the probability that less than 44% of them is going to prefer Pepsi. What we're going to do later is use that to actually determine like what's the chances of this happening, and is my initial statement incorrect or correct. All right, let's do this one. This is a little different on how it's worded. But let's start with what we've got. So what are the two pieces of information I need? Yeah. N and P. So N is 500 and P is 0.4. Those are the two pieces of information that I need to do any of this work. Okay, so now the next thing I can find once I have those two pieces is my mean and my standard deviation. So find me my mean and my standard deviation.
Also, how many digits should we cut off at? It's like 4, right?
Yeah, I would do the 4, especially if you're going to use that number and not the whole number. So I got 0.0219. And my mean is 0.4. Just want the curve. Tired of drawing them. All right, so I've got 0.4. What are they asking? Yeah.
Is it sort of like the continuity correction, like it wants to see between these two?
Kind of.
Like the error.
It's not a continuity correction, but it's kind of that concept where you're going in both directions.
Okay.
So have you ever, whenever you're looking at any kind of polling, what's typically at the bottom of the screen? After they show you the data and everything else, they'll say, this person has this percentage, this person has this percentage. Yeah, what's at the bottom? Yeah, typically it shows you a margin of error. Now, normally the margin of error is plus or minus 3%, and we're going to figure out why that's plus or minus 3% later on in another class or another lesson. But that's the concept here. So if I want a margin of error of 5%, where is it going to take me? So 5%, this is 0.0 or 40, right? So if I go 5% below, so margin of error would be the exact both directions. So below and above. So I'm going to go down to 0.35 and up to 0.45. And I'm looking at the middle. Because that would be the error is less than 5%. Does everybody understand why it's in between, even though it says less than? Okay. So if I was at 39%, what's the error? 1%, right? Is that less than 5%? 1% is less than 5%, right? and 39 would be in there. Okay, so it's a weird, this one, when they're looking at error, like the error, it's weird because typically less than would be looking at out here, like less than would be over there. But since it's the percentages or the error is less than that, the error in here is going to be less than 0.5 because I'm going to have 0.1, 0.2, 0.3, whatever, all those. And over here, the same thing. I'm going to have plus 1.2, those over there. So that's why it's in between those two values. So yes, a little weird, but that's why. All right, so I've got to find the z-score for both of these. Why?
There's the same distance part.
Good. You only have to find one, and you can use the same number on the other side. Very good.
And the probability, you would write it like P is.
Oh, so my answer is going to be written like this.
Like, would you be using the plus or minus 0.5,
Yeah.
or is it, okay, it's written that way.
So it's written like that. That's how you write your final answer. So since it's symmetrical, the same thing on both sides, I only need to find one z-score. It's going to be the plus or minus of that version. So I'll do the negative one. It doesn't matter just because I already have that answer done. Negative 2.28. Now remember, your z-score is always 2 decimal places because that's where your table is at. So I'm going to do that one and the plus 2.28. So negative 2.28 is 0.0113. And then positive 2.28 0.9887. All right, so what do I got to do to these two numbers? I'm going to subtract it. Because in essence, this piece over here is that part right there. So I'm going to subtract that off of the other one, which is going all the way over to there. Sounds about right. So 0.9774. So I have a 97% chance that the actual information is between those two values. Would that be an acceptable margin of error for your poll? Like if I said plus or minus 5% and I'm 98, almost 98% sure that that's correct. There is a reason they use 3%. And we'll figure that out later. And it's using that, we're also going to be able to figure out how many people you need to ask. Does anybody remember what I told you it was? 30 is the minimum you need to have actually have a normal curve. So this I mentioned this way back at the beginning of the class. So if you want to do a sample of the entire population of the United States, 340 million people, I only need to ask about 1,800 people to get an idea of what everybody believes, as long as it's randomly selected. It's crazy how little you need to actually ask looking at statistics. All right. So this one's got three questions. We're gonna do A and C. We're not gonna do all three. All right, so take a few minutes, work through and figure that out. So the bottom should be your calculations. If you're not getting those, ask. Now just look at the Z table for 0.88. Get 0.8106. And I'm also going to need negative 0.88 for the other one. Which is 0.1894. So what's the answer for A?
0.1894.
Yeah, so I'm gonna have to do 1 minus that because I want the other direction. So I'm looking at over here. And on this one, I'm looking for between. So 0.1894. And then for C, we're going to subtract those two. Which is what? 6212. Questions with those?
I'm sure, 0.0566.
Yep. That was your standard deviation.
Yeah.
So that's what gave me there. So that was the, actually, that was the P times 1 minus P over N. That's how I got that one. So if you notice, when I set this up in Desmos, I made that S and I used the S and my Z. So it's actually using that exact number here. So you don't have to retype it back in. And then I just have the P, the N, and the X. So I can just easily change those numbers. Definitely helps you do your problems out. Here's what I'll do. So you guys can use this. I will put that in as a slide in the notes. So you can see how I set it up. So that's there. Especially when you're doing Hawks and you have to do a bunch of these problems over and over again. Definitely makes your life a lot easier. Okay. So everything we've done so far, I keep saying randomized sample. It has to be a randomized sample. So what makes it random? Like we can literally just select so I guess how would you, if I wanted you to do a survey or something for the school and I wanted you to randomly select students, how would you do it? I'm going to ask 4 people in this room this. So I'm going to get 4 different answers. So if you watch your first shot at yours, raising your hand's a good thing. Okay, what's yours?
Maybe like have a list of everybody who's like enrolled, and then using a random number generator and like picking where it is on the list, like its position.
Okay.
So each one, but that's not like true random either. But
No, it is.
close as you can get.
That is a random way to do it. It was a random number generator select like that position. What's another way?
Honestly, I would just take a roster on there and just randomly point to people.
Believe it or not, that's not random. So inherently, we have biases on where we pick things. So if you're going to look at a sheet and you're going to randomly like just go like even blind, like just like hit things on it, you're typically going to hit things either right in the middle or around the edges for it. So
throwing darts at it wouldn't be random.
no, because like again, it's that type of concept. So it's like you would think, oh, that's random, but you have tendencies. So like if when she was saying you're going to pick is a random number generator, that's random because a computer doesn't have those tendencies. However, if I was going to say, okay, I'm going to pick your favorite number, like people have a favorite number, and it's like go that way, that actually ends up not being random. Yes.
Or the same thing, or like you have tendencies to do it.
No, because if you pick like if you shake them all up, like it's almost like the lottery or it's a ball, a thing of. So yeah, that could be random. But if you're looking at trying to pick out of 5,000 people, that would be rather difficult to do out of a hat. So, huh? Really big hat, yeah. All right, one more. Yes.
You could, that's kind of like his idea, but maybe you could like their idea. Maybe you could put their names in like alphabetical order, and then just pick random ones, like like for every, say, like every fifth name.
Okay. So that actually is a way to do it. You have the list and you pick every fifth one down or every 10th one down. That is a way to do a random sample. You would want the only thing that would be on you'd want your list to be random. You wouldn't want it to be in an order form. So you'd want your list to be random in that respect. All right. Would this qualify as a random sampling? Okay. It specifically says not picked at random. So no, this would not be a random sample. Would it be a sample? Yes, it is a sample. It is just not a random sample. So all the stuff that we've been doing would not work for this type of study or this type of information. However, and this is where you really need to look at how studies are done. Okay. So there is a lot of research being done, and not all of it goes through like a scientific board and everything else that really monitors what they're doing. So there is some that are done like this, where they'll pick the information they want to pick and they'll put out the study. And they'll cherry pick the information that they want to make it go their direction. So this is a possible way to do it. It's just not probably or statistically correct. Yes.
Like a lot of like personal health and like cosmetic companies do that, where they're
Yes.
like, "Ooh, it's scientifically proven that this new ingredient will help." But
Yeah.
then
There's
look at
nothing
the
backing it up.
study
And there used to be laws against that, or they couldn't whatnot, but those have become a lot more lax in their studies. And it's like they'll say they have a study done by this expert, but this expert, like when you really dig into it, it's not really a valid study. A convenience sample. Is a convenience sample random? No. So give me an example of a convenience sample. Not you, you've given me enough. Give me an example. There's lots of them. Yes.
Like, I know, choosing the people in this room as a sample. just
That's
compare-
convenient. Makes life easier on me. How many of you in any of your social media things have put out a thing asking the opinion of your friends? That's a convenient sample. It's not scientifically accurate, but it's convenient to get the information you want. Yes.
Second, related to that, like last class, you said like, oh, we send out this many, studies, I mean.
Oh, the surveys?
And you only get so many back, would that count?
So that one wasn't necessarily a convenience because they did do it random. They did actually send out the 150 random things. They just made the assumption that they were only going to look at the ones that came back without like, yeah. So it was that voluntary type of thing. So voluntary kind of is or is convenient. They just needed it somewhere. If they put somewhere in there the unknown, like this is how many people didn't submit it back, that would have made it a lot more accurate. But yeah, that's not technically totally convenient because they did do randomized how they were sending it out, but they just didn't get them all back. They need to have some kind of incentive to get them back, which is the key. All right, somebody mentioned this one. Systematic sample. So this is where you pick every whatever number of members until you get to the end of the list. The one key piece on this one to make it random is that it has to be a randomized list to start with. That's the one key piece. And this one is used a ton. Like this actually is one of those ones that is really used quite often. A lot of times when they're looking at schooling data and stuff like that, they will use the your student IDs to do that. And again, as long as that list is randomized, you're fine. Yes.
I remember hearing in my psych class about like something similar where, like for example, I know we don't use that door anymore, but like if you say set up in the main lobby and asked every fifth person,
Yeah.
it wouldn't be random because other people could come from the other exit or something.
Yeah, you wouldn't necessarily get all the people coming into the building that way because there still can come in other doors.
Yeah.
So you'd miss people like that parked on that side over there or over on the other side where you can come in the door over there. So yeah, unless every single person had to filter through this one door. So it's like if we went back to COVID where they locked everything down except for that one door so they could do their temperature checks, in that situation, you might be able to do it a little bit better. But even at that point, it's very hard, even if they were all filtering through the one thing, to keep track of the fifth person or the 10th person or whatever else coming in to be able to ask them that. So even at that point, it's still more of a convenience than a actual sample or a randomized sample. So, but yeah, this systematic sample, like I said, a lot of places use this for your randomized list of names or ID numbers and those type of things there. When you're typically doing any kind of survey, you don't want identifying information on the survey because that impacts bias when the researcher is looking at the data. So that's why a lot of times you'll see student IDs, social security numbers, those type of things used instead of the person's name or any other identifying information. Yeah.
Actually, one of the school emails sent out a study, and they asked me more questions, and during the recording, they gave me a number instead of a name.
Yeah.
Is that the same?
Same thing. Yep, exactly that. Because they don't like even it's like, okay, you have your person's name. It's like, that's not really, however, you can infer things about the person by their name. Like you can infer gender, you can infer like what nationality they are and all this stuff from a name. So you want to eliminate as much of that possible bias as possible when you're doing surveys. All right. So a cluster sample. So if I wanted to do a study in Norwich, I want to find out if the population would want a public pool. I don't think Norwich has it. So I want to do that type of study. I want to figure out if the entire population of Norwich wants a public pool. And I'm going to hire 10 people to go out and survey the population. Okay. How would the most effective way of me using those 10 people to go out and do this study? So would it make sense for me to take every single person in Norwich and randomize them and pick out, say, 30 people for each person to go look at and go talk to? Because what's going to happen if I hand you a list of 30 names and I had this person list of 30 names and so on and so forth, but they're just randomized all over the city. Yeah, I'm going to be bouncing all over the city, right? And that's not very effective. And remember, everything costs money. So if it's going to take you multiple days to do this, this is going to cost me more money to run the study. So cluster sampling basically says, I'm going to put you into everybody into groups. And then I'm going to pick, basically, I'm going to select random clusters to represent the entire population. Great example of that in the school would be, I'm going to take all the classrooms in the building, and I'm going to randomly select 10 classrooms in the building, and I'm going to ask every single person in those 10 classrooms for my study. That's a cluster sample. Is that random? Yeah.
Because usually, like, it was the classes example, we have some kind of shared trait
You do.
in what we're after, so.
So again, so in that respect for school, it would be depending on what my questions were. So yes, if I'm going to ask a question specifically about if you like math, that's probably not a good way to do that study. Because then if I randomly select a bunch of classes that are math classes, which is the number, like the biggest number of classes in this building on a regular basis, that probably wouldn't work out very well. But if I was going to do like the example with the pool, it might be fine. So how would I cluster the population of a city or a town? It would be
Break them into like different regions or.
okay. Blocks, neighborhoods, like there, you still have those basic breakdowns, right?
Like zip codes in a state, right?
Yeah. So it's like I could easily break it down and say, okay, these are the 10 zip codes I'm going to use in the state, or these are the 3 neighborhoods I'm going to use in the town. I'm going to ask everybody in those neighborhoods. So now when I send my 10 people out, I'm sending them to one neighborhood and they're literally going to knock on every single person's door. Okay, that would be clustering. The question goes is, okay, was that random? It kind of is. It's like, depending on what you're looking at, cluster sampling is a valid way to use random sampling. However, what are the downsides to it? What's the downside to it?
Kind of biased.
Why?
If you're picking like one neighborhood, like you tend to have people that kind of more sit. Depends on like what you're asking, but you're gonna have more similar group of people with probably more similar views. Like if you ask Jewett City a question versus Orange, Connecticut a question, you're gonna get 2 different biased answers. You know what I mean?
So there was an example and it wasn't in this book, but in one of my other books that I've used, that they had done a study, and it was a pool. So they looked at this entire town and they asked different blocks these questions. That's how they broke it down. So they asked, I think, 20 different blocks in this city. And the majority of people stated that they did not want a pool in the study. When they went back and looked at it, they found that when they broke it down, the blocks that were in the lower income areas all wanted the pool. However, when you got up to the middle class and the upper class families, those didn't necessarily want the pool because they had their own. However, the lower income population was more condensed, so they didn't get asked as many, but there was more of them as a grand scheme of the entire population of the city. So they were like 40% of the population, but they were crammed into like 4 blocks in the town. So like they didn't have as much of a chance. Like in the richer areas, there was maybe 50 blocks, but they were only like 20% of the population. Okay, so cluster sampling is good, but there's a better way to do it. So the next one is called stratified sampling. This is where we break the population into groups based on some kind of an identifiable characteristic. So the example I just gave was an economic one, which is quite often used. You can do this by political party, you can do it by sex, you can do it by income, everything. Any kind of identifiable characteristic. You break the population into those groups or strata, and then those are now your subpopulations. Now you can use your cluster sampling or your random sampling in each of those, so that your population, your random sample that you're going to get at the end is the same demographic of the entire necessary area that you're looking at. So if I'm looking for, it was 40%, what was it? 40%, and then 40% for the middle class, and then 20% for the upper class. Like that's my population. So I want to make sure that I pick 40% of the blocks in the urban area, 40% of the blocks in the middle class, and 20% of the blocks in the upper class. So that therefore my clustering is based on the actual population of the town in terms of an economic mindset. And in that respect, I would get a better representation of the views of the entire town. Does that make sense? So your cluster sampling works, but we might want to extend it out a little bit more to be a little more fair and remove some of the bias that can occur. Yes.
So it takes place the same way, it's just.
Yeah, so
It goes by group instead of random.
right. So you break the population into groups and then you random in those groups. And you can do any kind of random sampling you want in those groups. I just gave the example of clustering, but you can just do random too. That's actually how most of your polling data is done. So when you're looking at, like I said, 1,800 people, well, if they're looking at the 99% of the time we're seeing these is politically related. So it's like they want a breakdown of, I think it's like 42% Democrat, and like 38% Republican, and there's like 20% other or something like that. It's some breakdown like that. It's actually becoming a lot more of the independent split from the parties, but they would break down the population based on that. And they want, when they're doing their 1,800 people or 2,000 people, they want 40% of them to be Republican, 40% of them to be Democrat, 20% to be other. That's what they want to break down to being. So that's how they stratify it when they're looking for their random sampling. They want to make sure they hit those criteria. And typically what they'll end up doing is they'll just start randomly calling. And as they're starting to get closer to the end, where they're starting to hit their numbers, they'll ask those questions. And anybody who's like, so they ask the question again, oh, I'm a Democrat. They're not going to say anything. They're going to go through the thing. That one won't be used because they've already hit their quota for that number. So that's typically how they'll do those population studies or polling data. Is done in that stratified manner. You've seen it, like if you remember when you were in school, they were looking at like test scores. They break it down by every single category. That was actually one of the big things that they finally got rid of was with No Child Left Behind. You had to hit, it wasn't just the entire school population that had to hit a certain number. Every single one of the subcategories had to hit that exact same number. So it's like, so your special education population, your low income, everything, every one of them. And if any one of them didn't hit, you are not considered to be on track for the or whatever the criteria was that they were talking about. It's been a while. I don't remember it all now, but that's what they did. It was that same concept. Everything had to hit those numbers. All right. So let's look at one. Social research in Florida wants to determine the average number of children per family in the state. What's the population of interest? So what is the main population that I'd be looking at?
In Florida.
Just families? So I guess the question is there a difference in this respect?
I mean, if you don't have children, you're not a family, right? I don't know, like,
Be a family of one.
family with dogs, we counting dogs, I mean, what are we?
Well, I get, and that, but this actually is a very important question. So when you start to look at things, remember I said at the very beginning, the problem with this class is not going to be math, it's going to be English, right? What's the definition of family? Like that varies. There's a lot of different varieties of what people consider families now. So, like, and you made is it a family without children?
I don't
Like,
mean to offend anyone with dogs.
no. But that's like if you're just married and don't have kids, are you a family? Most people would say yes. Like that would be considered a family. So, or we look at extended families and stuff like that. It's like there's lots of definitions of that. So if I'm just going to look at families that have children and do my study with that, will that change the answer that I get at the end for all the families in Florida? Because at that point, I'm never going to have a family with no kids. So the smallest number I'm going to have is one. So, but there could be a whole group of families that don't have kids, that are just married and they just don't have children. So it's like, where do you consider that line? And that's actually one of the things when you're doing, if you're doing your studies, you have to put in your initial thing. It's like, what was your criteria? What was your definitions? Why did you choose this? What's your population? So while it sounds a very simple question, it's not as simple as it sounds. Like that's the question. All right, the rest of them are a little simpler. What's the variable we're going to measure? Yeah. Number of children. Can I have a half a child? No. Okay. What's the level of measurement of this one? Now we're going way back. 4 levels of measurement, right? Yes.
Are you asking this one or which one?
If you know them, I'll list them.
Docile ordinal interval ratio?
Yes.
So
So this one would be what?
you can have a ratio of how many children one family has compared to another. Like this family has twice as many kids.
Yes. So because you're going to be able to find mean, which they're looking for is the actual, like the average number. So yes, I would say ratio in that case. All right. Discuss the steps that would be necessary for each of the following sample methods. How would you do a simple random sampling of all the families in Florida? How would you be able to get a list of all the families in Florida? What's coming up in 6 days? No. Census is every 10 years.
Yeah, but.
What's in 6 days? It's tax day. What does every family have to file? Their taxes. And on that tax sheet, you have to state how many dependents you have and everything else. Actually, everybody has to file taxes, not just families. So I could easily go to the state government and say, I would like a list of X, Y, and Z. And believe it or not, all public information. You can get that. I can actually go to this government, get a list of every single person who's registered Republican, every single person who's registered Democrat, every person. I get all this information. It's all public. You would think, no, it can't. It's all public information, as crazy as it sounds. So once I get that list, we can do a random sample of that, right? We could go through and pick like every 10th person or use a random number generator to randomly select those numbers. I can assign them all numbers and have the computer spit out 100 people or whatever else. I can easily do that. How would I do a clustered sampling of the entire state of Florida? Probably the easiest one would be zip codes. Now, are all the zip codes in Florida or in any state equally distributed based on the population? No. Sometimes you have a town with very few people in it, and sometimes you have a town with a lot of people in it. They might have multiple zip codes, like in those cities. Like Miami, I guarantee has a lot of zip codes, but they might have more than Oshkosh, B'gosh, Florida. And I have no idea if that's an actual town in Florida. Yes.
Like, I don't towns when they, I mean, states have like voting areas that distribute the population more evenly, or am I thinking?
They have voting districts,
Yeah.
yes. However, those aren't very well distributed either.
Okay.
There's that whole gerrymandering concept of it with the voting districts. So those are not very organized either. There really isn't a great answer to this question. Zip codes is probably the easiest one to type do. But there is a problem necessarily with that, right? And that goes back to where we're looking at how would we do necessarily like a stratified sampling? Because if we're looking in Florida, depending on, now remember, like Florida is typically the retirement state, right? A lot of people go down there after they retire and whatnot. If their kids aren't with them, or do they count as children?
What if you clustered it by like different school districts?
School districts probably would be the best way to go. I actually kind of like that way. You might miss some of those, but at that point, if I'm not, so even if you're homeschooled, you're still in a school district.
Right.
So when I'm looking at school districts, that's going to give me the area that I'm going to look at. So now, how would I change it for stratified sampling? Yeah.
If you get the same list from the state government and then just divide it into demographics, where you can pick from each like group.
Yeah, so we can look at different demographics. So what kind of demographics would you want to look at for this? Yeah.
Maybe straight versus same-sex couples.
Okay. Okay. That'd be a different way to look at it.
By income?
Okay. What are we trying to measure? Of children, right? We're looking for children in the family, right? So what would have, so income probably would have a breakdown there. We could definitely, I would say we could collect that data. I don't know if I want to break it up that way. Same thing with the same sex versus hetero families. It's like, I probably would want to collect the data because that would be an interesting way to look at it. It's like, is how many number of children and the families and stuff there. My guess in Florida is it's probably a little skewed to one direction.
Yeah.
But what about ethnicity to break down? Especially if you're thinking about in Florida, you have a very large Hispanic population, things like that. the ethnicities actually do have a very large impact on family size. Hispanics typically have a lot more, or a lot more family oriented and things like that, with a lot bigger extended families and whatnot. So, like, again, like when we're looking at stratified data, we want to break it down in a way that is easy for me to be able to pick and choose where I want to look at. And I guess depending on what my end result is, depends on what I want to pick there. But just because I'm using that to break down the groups doesn't mean that's the only data that I need to collect. I can still ask you any questions in the world. Like, I can ask you a bunch other than just the average number of kids or the number of kids you have. So, all right, we won't do the last one because we kind of already talked about that. So we are done with chapter 9. We'll be moving on to chapter 10 next week. So I will see you guys on Monday. No problem.